Welcome back, everyone. I am inviting you to episode 12. We're not really going to make a game or anything for this episode. We're actually going to be doing my homework. That's right. So, as you can tell, I'm actually in a linear algebra class. Sadly, my math classes are far behind my other classes for my computer science major. But one of the things, and actually this homework isn't even, it's not even due yet, but the test that covered it already happened. But one of the things that we have to do is we basically have to solve systems of linear equations, and basically we have ax equals b. So I'm not really going to explain all the details of how it works, but anyway, the whole point of this problem is you take a and b and you reduce a down to a reduced row echelon form, augmenting b to the side of it. That way you can find out what x is. And so basically this is a pivot position in the reduced row matrix, and so is this, and so is this. And so this column and this column right here, those are not pivots. And actually, if we're just talking about this part of the matrix, then we only have one column that's not a pivot, and that's a free variable, which is here. So this other side of the equation is going to end up being over here without a scalar being multiplied by the vector, and then here we will have a scalar multiplied by a vector to free range that free variable. So if you've taken linear algebra, or if you are taking it, you probably will know what I'm talking about, or might have to recall what I'm talking about. But if you have not taken a linear algebra class, you most likely will not know what I'm talking about. And so if you want to still watch this episode, you can just kind of try to enjoy just watching what I'm doing, but you might not really catch on. But anyway, my goal, since this is already pre-programmed into the calculator, my goal is to be able to go from here to actually to here. So without me having to do any work on my own, I'll just be able to enter the numbers straight into the calculator at this point. And that's what we're going to be working on. Okay, here we are back at the old handy dandy calculator. And I want to show you, I have stored in matrix A right now this this matrix from the problem, and I already tested the answer, so I already know the correct answer. I'm supposed to get these vectors right here as a solution given that matrix. And actually this is an augmented matrix, so the 12, 31, 45 on the right hand side is actually the B. So what I need to do here is I need to write a program that's going to get this into row echelon form, I mean reduced row echelon form, because that's actually two different things. So if I do ref of matrix A, it's going to give me this. And what I'm going to do is I'm going to write an algorithm that searches, starting from the upper left, for every row that has, or every column that basically has a pivot, which means a number that increments down. So this column, for example, has a 0 here, so it's not a pivot column, but this one is. But since this one is, then that means that this one can't be at all, because there's only 3 numbers high, so actually you can only have 3 pivots total for a matrix that's only 3 tall. So, but the key is to find which columns. So the first, second, and fourth are the pivot ones, but the third and the fifth are the non-pivot ones. And I'm just going to I'm going to assume that B is just a single vector. and A can be whatever we want it to be. So it'll be any size, but we're going to assume, of course, that the height of B matches the height of A. So then our goal is to get a 4 vector, because it's going to basically be the augmented side. So this is 4 across before we get to the augmented, the right part, and that's going to give us these vectors right here, which are added. So this is the free variable. These numbers come from, so the 3, 3, 0, 1 comes from the right side, and the negative 1, 1, 0, that actually comes from that comes from this row. Negative 1, 1, 0. Well, that comes, let's see. So this is if this row represents x, y, z, w, then it would be, well, I have the equations up here actually. So you would get that. So you get x plus z equals 3. Y minus z equals 3. And w equals negative 1. And we get that from here because this is the x, so x plus y, or x plus z equals 3. So you can, if you get z to the other side, then it's like negative of this. So you get x minus z equals 3 minus z. And that's what we get over here. So basically everything but z at this point can be described by a combination of both what the right hand side was, which is here, and z itself. But the important thing is we're also including this third row here. So as you can see, it's a 0 and a 1. And what that third row is that's actually the z row. So this is x row, this is y row, this is the z row. So this row right here is going to have 0 for the column, for the static part of the solution. Forgive my terminology, but it'll have 1 for this free variable, because this free variable actually represents z, so that'll just always be 1. So basically what we need to do is we need to find how many free variables there are, and we need to make one of these vectors for each of those free variables, and then we need to find out what numbers go inside of them and correctly fill them. So I'm going to start off by making a new program, and it's going to be, let's just call it MATSOL for matrix solution, and we're gonna ask. So we're gonna prompt x, and we're gonna prompt y, and what that does is that's gonna see basically how big our matrix is going to be. So we're going to look at A for this point. So given A, we want to know how big our matrix needs to be. So we're going to make it clear that we're asking for A. We want to know how wide it is and then how tall it is. So in our case, I think we had 4 wide and 3 tall, but we need to add one for the B when we actually store it in the matrix. So I'm going to store. So I'm going to store dimensions so y comes first, I guess. And then x plus 1 is going to be the width, because we're going to have the augmented matrix. So we're going to store that into, well, let's use some, let's use, I guess C, because I need to save A for the moment. And so we can loop through. For A is 1, 2, x plus 1. And then for B is 1, 2, y. And I'm not sure if I can do this, but let me try prompting for C of BA. I'm not sure if I can do that. But yeah, let's try this out. It might error though. Okay, so let's say the x is 5 and the y is 5. Okay, so that's a syntax error. Okay, so what we can do is we can actually do this nice and we can make this nice and handy. So we can display what row and column we're looking for. So if we're looking for row, and we can prompt, we'll say prompt C. C stores matrix, we'll store it as matrix C. Did I do what? X's first? Yeah. So we're going to display, oops, A and B. Which row it is going to be the Y, and which column it is going to be the X, of course, because we're counting how far in the X, right? So how many columns, or how far across the row, basically. So which column is it? So that'll give us, that'll fill up the matrix. Now we want to RF the matrix. And we'll store that into matrix B. So now we have a reduced row echelon form matrix B. We know the width. We know the width of it, and we know the height of it. So we can store 1 into our, let's use S and T. So I guess we can do a loop. And then what we can do is we can have a counter. So we can store 0 into C, and so we can check, well, matrix B, S or T comma S. Well, no, let's do this. Let's say we'll say while T is less than or equal to the height. So we'll say, well, T is less than or equal to Y. By the way, this is the first time I've ever programmed this, so I'm just trying to figure it out as I go. And while S is less than or equal to X. So we're going to be searching through the augmented matrix, the left side of it, and we're going to make sure that we never go out of bounds. So as soon as we get off the matrix, that's our cue to stop. So C will be the count of rows. So I'm going to store, so if matrix A, I'm sorry, matrix B is what we're working with. If matrix B T comma S equals 0, now remember, we don't need to do row swaps or anything because we already have reduced row echelon form. So if it's 0, then that means we need to move right. And if it's not, I think we need some kind of flag or something. So let's use F. So if 0's an F, then that means we're searching for, I guess, a pivot column. Yeah, so if it's F, I guess we're searching for a pivot column. So let me think here. We need to go to the right. Well, if it's not 0, then we add 1 to C. So because we have another count for the pivot column, and we can add our S into the current list part of list 1. So basically I'm adding to our list of columns, I'm adding that column, I'm counting that column. So I'm basically saying, like, okay, so this is a pivot column. Or maybe I should be adding the free variable columns instead. You know what I'll do is I will make a list. I got an idea. I will make a list that every time I move to the right, instead of counting the columns, well, no. I suppose I can keep one count, but instead of making the list based off the count, I can make the list the width of our matrix augmentation. So I want to store, instead of storing S into it, I'll just mark it. So every time I increment S, I'm either going to mark it with a 1 or a 0, I suppose. So we want to increment S. And we want to increment T. So we're basically moving down diagonally. That's what we want. So 1 stores S, or list 1 S. Otherwise, if it's not, then what we can do is, I think we can just move to the right, because we know that can't be a pivot column, basically. So we just want to increment the S. Right, okay, so we're going to increment the S either way, but we're not going to increment the T for this one. So we're just going to we're just going to increment the S, but we're going to store 0 into our checker. And we're not going to add 1 to C. Okay, so from this, if that works correctly, which I'm not totally sure if that's the correct way to get the pivots. I believe it's possible. However, I'm not sure. What if you have like a pivot on the first and then a pivot on the second row, but then you have a pivot like down here for the third pivot? Although I don't think that's possible. I think they would have swapped the rows. So I think this will correctly count how many pivots there are. So I can store 0 as D, and I can add 1 to D, even though that kind of seems like, why would I add a 1 to 1 either way? Well, it just makes it easier. I don't have to subtract. So I know how many pivot columns and I know how many free variables there are. I might as well just make a variable for each, because I'm not trying to really optimize a game loop or anything crazy like that. I'm just trying to get a program that functions. And it has this very simple short algorithm. So there we go. We counted how many pivot columns and free variables there are. Now let me see. Let me do a loop here. So I'm going to loop from for A is 1 to the height. Or I'm sorry, for A is 1 to X. So that's going to be my loop, and the first thing I'm going to do is I'm going to output the reduced row No, that can't be right. Well, it is from when A is 1 to X. I think I'm going to output the very right hand side. if it's included. So I'm going to store 0 into B. And I'm going to say if L1 of A equals 1, which I believe that means it's a pivot column, then B plus 1 stores B. Yes. So, yes. Okay, so for A is 1 to X, so I'm basically going to go down this list. So I'm going to show you my example here. So see how the 3's and the -1, those were the right hand side. However, there's a 0 for the Z as a free variable. So that's basically what this else is doing, is it's displaying a 0 there, and otherwise it's going to be incrementing B, but only when list 1A is 1, which means only if it's a pivot. So I'm going to be displaying the very right hand side, which is X plus 1, but the Y for it. So, or not the Y for it, the B. Right. So one thing I want to do though, and this is going to be for debugging. Yeah, this is going to be for debugging. So basically, I'm not going to ask right away. I'm going to store matrix A into matrix C to test this. Okay, so I should get 3, 3, 0, -1 when I run this program, and I don't. I get an error because oops. Because T and S apparently don't exist. Matrix B, what's T? What's S? 4 and 5, what? That can't be right. Well, T is less than or equal to Y and S is less than or equal to X, is the only way it should have gotten in there. T and S. Oh, you know why. My bad. X is 1, 2, 3, 4, and Y is 3. Since I did the debugging thing, I forgot that I actually had to set X and Y to test this correctly. Oh, perfect. Oh, that works instantly. Okay, that is awesome. So that gives us our first column, and then after that, all we have to do is we have to do like a wait here, I guess, a pause, just so that we can read the numbers, and then we're gonna have another loop. Yeah, we're gonna have And this is going to be the hardest part, I think. And we have to get the second row right here. So we have to get the S. We have to get the negative 1, 1, 1, 0. So we have to check for each free variable. We have to go through and we have to find for each free variable what each variable depends on it for. Which means that if the free variable is our variable, we put a 1. If it's not, then I believe we put a 0, I believe. But if it's a dependent one, then of course we solve for it based off where we are. So looking at matrix B, this will make it more clear. So as you can see, this third row tells us, you know, for x, that we have to put a negative 1 in the first spot, and then for y, or for whatever this row represents, y. Ooh. We have to store which row we're in. Oh, this is getting confusing. Okay, so instead of me storing a 0 or a 1 into this list here, what I want to do is I want to store our x. And the reason is or I don't want to store our x, not even our s. I want to store our t. Do I want to store RT? Hold on a second. 1, 0. So this is our x. This is our row that we eventually solve for x. Or when we're looking at the z column, we know to apply this first number to x, the second number to the y, and then 1 is applied since it's our own free variable column, and then 0 is applied for the last column. Okay, so I guess we just go in order, so it doesn't really matter. So we just basically put, if we reach a free variable column, then we just put a 1 or 0 depending, and if we don't, then we put whatever applies to that pivot row. So I'm running out of batteries. I'm going to be right back after I plug this in. Okay, we're back. Okay, so we're going to go down here. We're going to loop through once for each free variable. So that's D. For A is 1 to D. So yeah. Yep, that makes sense. Okay, so for each D, we're also going to loop, and we're going to pause at the end of those. So, but we're also going to loop for b is 1 to the height of what we're doing. Or I'm sorry, not the height, the width, because that's how many variables there will be. Then, oh, sorry about that. So then we want to check our current, I guess our current current variable. I'm not sure. What if we have, what if it's a pivot column, but there's other variables above it? Wouldn't those get canceled somehow or not? I think it makes all the other ones zeros, possibly. But if I'm wrong, anyway, let me try to just go with what I was thinking. So in our case, we're going to have 1. D is just going to be 1. X is going to be 4 for our example. And we need to print out -1, 1, 1, 0. So the third one is going to be the special one because that's going to be our pivot column. And we're seeing if it's the same as the current pivot column or not. So we have to check if the current list 1 equals 0 or not. Okay, so if it equals 0, then that means we are in a free variable column. So we need to check if let's see if how do I know if the current variable, because A is going to be like 4 or 3 at this point, because it's on the Z column. But how do I know that that's the one that I'm looking at? How do I know that my A is matching or wait, A is 1 to D. So A is going to be 1. How do I know that that's the first free column? Let me add something really quick. Instead of storing 0 as L1, let me store negative D. After I add 1 to D, because D is 0, right? Yeah, so I'm going to add 1 to D, and then I'm going to store negative D. And then when I come down here and I check, that checks if it's 1. But here I'm going to check if it's less than 0. Or I can say if it's less than 1. Either way, it's not going to be 1. But if it's negative 1 or negative 2, it's going to tell us which which one it is, or which count out of D that it is. So if negative L1B equals D, okay, then we're going to put a 1. Else we're going to put a 0. But if it is 1, then that means we have to put whatever that column is. We need to put a little loop here. Do we use C at all anymore? I don't think we use C. No, we might use C. Let's use E. For E is 1. So we need to count through our free variable columns. Oops. So if list 1 no, we need to count through our x's. So for E is 1 to x, or actually, let me do this. 1 stores E, while and then we'll put 0 stores F. Okay, so while F is less than A, if list 1 let me think here. So I'm gonna loop through and see which one we're on next. So if actually, instead of doing that, I got an idea. Let's just start here. So 1 stores E. And then here what we'll do is we'll just do a while loop. While list 1 E equals 1, E plus 1 stores E. So as soon as it doesn't equal 1, we leave the loop. So actually I'll store 0 into E there, and I'll add 1 into E here. So E plus 1 stores E. So this is forces to E to increment, and then while it equals 1 we're going to skip through. So basically we're only going to go to the free variable columns. Okay, so then E is going to be our tracker. And then B, let's see here, B tracks where we are on our output. So basically if list 1B is less than 1, then that means we know we're in a free variable column. Okay, so we display 1 if it's our column. Because it equals D. But otherwise we want to display what the X is there. I don't know if it would be list 1B. Wouldn't it be list 1E? Because that's the column we're looking at. Yeah. The problem is the column we're looking at will always be less than 1. So I don't know why I'm checking. But I need to go down the column. So if B goes from 1 to X, well, that's once for each column. Oh, you know what though? This is list 1B. Because I already selected that I'm looking at a certain column. Okay, now I'm for each column, or for each free variable column, now I'm going to look at each column for each of those columns. And that's when I check if it's less than 1. That's when I print whether it's a 1 or 0, and if it's not, then that's when I look at the row that I'm, or that's when I look at which row, or which pivot variable column I'm in. So let's see here. I want to display -1 in this case. But where am I to display -1? I'm here. So basically I got to here. I'm looking through this. Or I'm looking through all the columns to check whether they're free variable or not. And if it's not, then I should just put whatever's in this column actually. Yes, that's what I should do. So let's go to matrix solve again. I'm figuring this out. It's just taking a while. So basically, the column I'm in is column E. But the column B is what's telling me whether I'm looking for that certain one or not. So I need to increment down. So I need another incrementer. I'll call it 1. So 1 stores F. So I need to display F. Well, hold on, matrix B. The height's going to be F. The X is going to be E. And then I need to increment F1. Just in case, oops, just in case F needs to get hit again. Okay, so let's try that. So 3, 3 is -1. 1, -1, 1, 0. Okay, one last thing. I need to negative that. Actually, 2 last things. I needed to negative that because you solve for the variables. Remember, I moved them to the right hand side of their equations. And for each of these, I want to clear the screen. Okay, so basically I get 3, 3, -1, and then I get -1, 1, 1, 0. Okay, that works. Okay, so I'm going to go to the matrix again, and I'm going to erase if 0 then. I'm going to come down here and I'm going to erase the end, and I'm going to erase the matrix A stores it. And we're going to test this out on my homework. So let's go test this out to see if we get the correct answers. Okay, so here we go. This is another problem. I am going to enter everything you see here into the program. So I ran the program here. I have it all ready to function, all ready to go. And let's go ahead and enter it in. What I see above me is a matrix that is 4 wide, so I'm going to enter 4 in for X, and it's 3 tall. Okay. So now I need to enter in all the numbers. So -3 is going to be on uh-oh. Well, let's hold on a second. Let's see if I enter it in going down or something. Yeah. Okay, so I need to enter it in going down the Y columns, which is fine. It's just a little different than reading English, but it's more like reading Chinese. Okay. Okay, and it's also asking me for the rightmost side, because it's of course a augmented. Okay, so 1, 2, 0, 1. Okay, so here's what I'm given for the possible answer. So let's try it out. 1, 2, 0, 1. Okay, and then I have something with a 1 on the second to last number. So let's go ahead and see what the next one is. Oh, and it says 3310. Okay, so 3310. And here's our ultimate test. We're gonna see if that really worked. And we're loading. And voila! It worked. So congratulations to me, although I didn't have it output this matrix, so I'll have to actually go and actually look at what, you know, what B actually is, but it looks like our program worked. And if it doesn't work for all the rest of the problems, since I have like around 20 more problems like this, then I'll let you know. But otherwise, I'll probably just try to finish my homework and move on. Thanks for watching, and that's at least most of episode 12. Oh, the very next problem. Why me? Why me? Why me? What is B? B is 4. My matrix is only 3 tall. That is not good at all. And that rhymed. So somehow some way I'm increasing B too much to 4. 0's what starts as, so list 1 oh, wait a second. So B is, how did B become 4? Oh, how did B become C? It thinks there's 4 pivots, which actually is impossible. Somehow the first 4 variables of list 1 turned into 1s, which actually that's wrong. I don't know how that happened, because it shouldn't have. Considering that my matrix is only 3 tall. My y is 3, I believe. Yeah, so actually something didn't work quite the way it should have. Yeah. 1 stores S. Negative D store as S. What is D? D starts as 0. Let's take a look at our reduced row echelon form. Okay, so we go right and down, right and down, right and down. And then we get out of our loop. Actually, when we shouldn't. So basically okay, so we have to account for another special case, which is the fact that well, I figured out what the problem is. Let me go and record that. And we're back to our normal programming environment. Basically, my problem is when we have a reduced row, when we have a wider matrix than a taller matrix, then we have to account for the fact that our t can go beyond the y, but we still want to be incrementing our s to find out what each column is. So one thing that we can do, and this might actually just be a little simple hacky fix to this, but hold on, this is a while loop. Oh, this is a while, and this is an if then, else, and end. So this is after our while loop. So right here we can say while t, oh, sorry about that. Anyway, my camera seems to be slowly falling, so I'm just readjusting my calculator to account for it. Anyway, while t is less than or equal to y, t has not become y yet, which means we haven't reached the end of the matrix. So or I'm sorry, well, s is not less than or equal to x. Anyway, we haven't reached the end of the matrix because t reached it first. T reached the bottom first. So what we want to do here is we know there's no more pivot columns, so we can just increment s has been incrementing each time, so we don't need to increment till after we do what we need to do. But basically we need to do a no increment one, so we need to do d plus 1 stores d, negative d store. We need to do basically this section right here. Excuse me. Negative d stores list 1s. Okay, so I'll be back after I test this. Okay, so basically the problem was this f right here, I wasn't incrementing it in the right spot. Actually no, not that f, I'm sorry, the setting of f to 1. I was setting it outside of this loop, so f was getting too large. And then another thing is I also added an if statement at the start of the program to check whether I'm restarting or not, so I can keep the same matrix. So the same matrix that I've been testing with, I'm going to put 0, which means keep the same matrix in there so I don't have to retype it in. And it gives me that, and then it tells me different sets of numbers. So I'm going to enter these in. So right now I have the first one entered in, and -2010, and the next one is going to be -2. Oh, looks like this one might be wrong, unless it's talking about this column. Let's see, 001, 0, 0, -3, 1. Let me check my matrix C to make sure I entered in the correct matrix. 1, 2, 3, 9, 1, 3, 6, 10, 30, 40, 0, 0, 2, 6, 2. So something's wrong here. But yeah, let me figure out what it is and I'll get back. Okay, here's the click of no return. Let's hope that these are correct. Yes, they are. I'm going to show you exactly what I did. It's actually one simple variable. So, whoa, is that the camera lens? That's so horrible. I hope it's just dirt and not scratched. Anyway, let me go through and show you. Oh, I think we passed it. Yeah. See this? This was a -L1b equals D, but actually it should be equal to A, because D is just like the total number of free variable columns that we have, but we're checking if it matches the current one. So the current count of them that we're at, and that's what A actually exactly is. So A is the variable that I was looking for there. So if I run into any more problems, then I'll catch you guys again. Otherwise, it might be a finished episode. Okay, I accidentally entered the matrix in wrong the first time and guessed no solution, so I was getting them wrong, but here goes nothing. Sweet. And here's another problem that I copied exactly from the calculator, every single answer. And let's see how much work our calculator did for us. Oh, how nice. All correct. Well, let's move on to the next one. Alright. And we have another problem. Let's see what this gives us. And oh! There we go! Refresh of the page for a little flicker, and it automatically scrolls down back here, and all those nice pretty green check marks. You won't believe this, but I actually clicked yep before I pressed record. This was a strange one. I hope that it works. Whew. I was scared. Oh yes.